Let's talk about lasers. When people hear the word laser, they typically think of a sci-fi film or a powerful, dangerous cutting tool. If they're a little more realistic, they may think of laser pointers like the ones commonly used in a classroom. We probably think of lasers as being rather rare or high-tech. In fact, most of us probably use lasers on a weekly, if not daily, basis. Reading barcodes, printing, and sending telephone messages are just a few examples of things that use lasers. So, what is a laser? To understand that, we need to understand something about fluorescence. First, let's go over a few terms. Luminescence refers to a molecule emitting light. Photoluminescence means that the light is emitted because of electromagnetic radiation that hit the molecule. There are two types of photoluminescence. Fluorescence is a type of photoluminescence that occurs when an electron absorbs energy from electromagnetic radiation. This energy excites the electron, meaning that it causes the electron to jump to a higher energy state. The electron is then attracted back to the atom's nucleus and instantly drops in energy state. It does this by releasing energy in the form of electromagnetic radiation. Now, we know that light can be described as both a wave or a particle called a photon. Things will be easier to think about if we consider electromagnetic radiation as photons rather than waves, so just bear that in mind as we move forward. Sometimes when an electron becomes excited, it takes a while before it de-excites and returns to a lower energy level. In this case, the electron is said to be metastable. A common analogy for something being metastable is a ball in a trough above the ground. Normally, the ball would roll as far down as possible, all the way to the ground. But when there is a ridge in the way that the ball would have to roll up and over, it will stay in the higher trough. If something were to push the ball up and over that ridge, it would roll all the way to the ground. Because the ball could still be lower down, the trough is said to be a metastable state. The ground is considered the stable state because the ball can't roll down any lower. In the same way, some energy levels are metastable, and an excited electron will stay there until something pushes it, so to speak, and it drops to the ground state, where it is stable. If this is the kind of photoluminescence that takes place, it is called phosphorescence. The metastable electrons usually return to a lower energy state after a few minutes or so. While that may sound like a new idea, you have probably been interacting with it ever since you were a kid. Glow-in-the-dark toys use phosphorescence to create their glow. A more technical application is determining the age of ceramics found in archaeological digs through a process called thermoluminescence. When some ceramics cool after being made in firing, the excitation energy in some of the electrons is frozen in place. If the ceramic is heated again, then that energy can be released. Depending on how much light a ceramic releases, we can determine how old it is. Let's come back to our question from earlier. What is a laser? Lasers are the result of photoluminescence that creates radiation with exactly the same wavelength and are coherent. Being coherent means that the waves are propagating in phase with each other. Their peaks and valleys exactly match up. Essentially, it is a whole bunch of photons that are behaving in exactly the same way. The way that we get this to work is by creating a population inversion. This means that the majority of electrons in the material creating the laser are in a metastable state. There are lots of different ways to do this, but one of them is by using electricity to provide the energy. After a population inversion is achieved, a phenomenon called stimulated emission takes place. This means that one of the excited electrons spontaneously returns to a lower energy state, releasing a photon with a given frequency. That photon then passes another metastable electron, and causes it to release a second photon with an identical frequency and phase as the first. This process continues until there is a whole army of photons, all with the same frequency and phase. Voila, we have our laser. This is actually where lasers get their name. Laser is actually an acronym for Light Amplification by Stimulated Emission of Radiation. To get a more intense laser, mirrors can be placed around the material that has the population inversion. This way, the released photons can bounce back and forth through the material and cause even more metastable electrons to drop to a lower energy state, emitting more photons. If one of the mirrors is semi-transparent, then it can let out the photons as the laser beam. Lasers can be many different colors or no color at all. What we see as colors are just photons with a specific range of frequencies, but photons can be any kind of electromagnetic radiation, even ones that our eyes can't see. In fact, the first lasers, built by Charles H. Townes in the early 1950s, were actually microwaves rather than visible light, and were called masers. The kind of laser produced just depends on how much energy the metastable electrons release during stimulated emission. So besides being a cool word and inspiring fun sci-fi films, why do we care about lasers? There are actually lots of important uses for lasers. We have already mentioned some of them: reading barcodes, printing, and sending telephone messages. Lasers are also used in medical procedures because they use only one specific wavelength and don't disperse as much as mixed light. For example, a detached retina can cause someone to go completely blind. By using a laser to create a small spot of scar tissue, the retina can be reattached and save the person's sight. Other non-medical uses include reading CDs and DVDs, inducing fission, surveying, and laser shows. Lasers are an incredibly useful tool and are relatively simple to understand, and they are an important part of everyday life. So you don't have to live in a galaxy far, far away to see lasers in everyday use. Instead, just head over to the grocery store.